Hello class, we're going to show you some solutions for the Chapter 2 assignment. Got them in this folder right here. I hope you're submitting your stuff in a folder. That's what you want to do. Here's the first program. And this one's a relatively simple one. Notice I put some comments at the top of the page. That's a good practice. You should do the same. And you should also put comments in your code as well, indicating what's going on in your program. Okay, well, we're prompting the user to enter the first name and the last name. When you use input by itself, that's good for entering a string, and of course a name is a string. Use proper variable names, like don't use X and Y, use first name, last name, or something to that effect. Names with underscores are the Pythonic way to go. That's the standard convention in Python. Okay, and then we want to generate the output with the print statement here. So let's give this a try. I'll be Guido. I'll be Guido's cousin, Guido Smith. And there's how it runs. So hope you're okay with that. Well, notice that the comma in between these three print items automatically inserts a space. That's an important point. Guido made it that way on purpose to make it easy for us. All right, now let's take a look at the second one. All right, this time we're going to convert a length in inches into feet and inches. There's a table on page 54 that you should refer to. It has the mathematical operators there. And in this case, we need a couple of special ones because we want to get the integer value of the feet after we divide by 12. Well, that means we have to do integer division, which is 2 slashes, not a single slash, 2 slashes. That gives us a whole number value. And we also want to get the remainder, and the operator for that is a percent symbol. That will give you the remainder after dividing by 12. So let's see how this one works. Give it a run. I'll try 75 inches. That would be 6'3". Yeah, that's correct. I'll run it again with a different value. Okay, let's try 22 inches. That would be 1 feet 10. So it looks like it's working okay. Hope you're all right with that one. Let's take a look at 2'3". All right, this one also requires you to use table 2.3 on page 4.4. This one also required you to make a constant. We wanted you to create a constant. On page 73, 74, you can read about constants. Constants are values in your program that aren't going to change, hence the name constant. And pi is a good example of a constant. Another example here in Pinellas County might be sales tax rate equals 0.07, right? Those are values that don't change unless changed by legislation. So always use uppercase for your constant names. That's a standard that's used in all programming languages, and we want you to adhere to it too. Now we want to get the user input, and according to the requirements, we wanted a number that could possibly have decimals in it. Well, that means we have to input a float. That requires that the float function be used to embed the input function. Notice the two closing brackets here. We've got the entire input function embedded in the float function. That's a requirement for entering numbers. Now, once we've got that input, we can use the formula for circumference, which is pi times the diameter, and then we can get the formula for the area, which is pi r squared. We can get the radius by dividing the diameter by 2. And here's another operator that's there on page 54. Double asterisk is how you indicate exponentiation in Python. That's how you do exponents. Now I could have said pi times radius times radius. That would have been okay too. And I could have even said pi times, I could have left this step out and could have said pi times diameter over 2 times diameter over 2. But I thought we should take a look at this operator. Okay, so then we generate the output. Now, we want to format these with 3 decimal places, so that means you have to use the format function. Whenever you use the format function, you need 2 things inside the parentheses. What you want to format, followed by a string indicating how you want to format it. In this case, we want to format it with 3 decimal places as a floating point number, so that's what the 0.3 means. Here we're going to format the area with 1 decimal place as a floating point number. So let's give that a run. Let's see how that works. I'll try I'll try 12.5, which I believe was the example in the sample output. And yeah, that looks like it's working okay. So I hope you're okay with that. And one more, 2.4. This one has an extra wrinkle in it because in this one, we want you to be very careful in your output that you do not have a space after the $ in the output. And in order to do that, we have to use the special SEP operator here, which you can read about on page 66 to 67. That's the SEP operator. But you can also need to know how to indicate thousands in a formatted number. And you can read about that in comma separator section on page 70. But the first thing we want to do is get the sticker price. Now I went for float, but we could have used an int. Typically, I don't think you see 2 decimal places on a sticker price on a window, maybe. But anyway, we could have done it either way here. Now, then we want to do the math. Notice I'm putting little comments in here indicating what each part of the program is doing. You should do the same. And we're going to calculate how much was saved by multiplying the decimal 0.15 times the price. And then we're going to find out the reduced price by subtracting that from price. And we've used another variable here called price 2. Now, you wouldn't have to call it price 2. You could call it discounted price or reduced price. That would be fine too. But here's the key. Now, in the output, we want the $ to show up, and we don't want any space here. Now, this comma would normally generate a space. So we can cancel that with the SEP operator. This SEP operator here there's nothing inside the string. It's just 2 apostrophes. So what that means is separate these print items with nothing. So that'll cancel the space that a comma normally produces. And we do the same thing down here. And then one other point, that comma is going to format it for thousands. You put the comma before the decimal place. So to be thorough, this here means format with 2 decimal places, but also insert commas for thousands as necessary. So let's run this and we'll give it a try. I'll try the same value that's in the sample output, 32,500. And there it is. Hope you're okay with that. Okay. If you have any questions about that, you want to get back to me, send me an email, ask me a question, I'll try to respond. And there's one more thing. When you submit, you need to know how to zip. I think most of you do know how to do that. We want you to submit a zip folder. How do you do that? Right-click on the folder name, select Send to Compressed Zip Folder. If you have a Macintosh computer, it would be Send to Compressed, I forget exactly what it says in a Mac, but that will make a zip file with the same name as your folder. That's what you want to submit to the Dropbox. All right. Happy coding.